Hello, my name is Nick Harvey, and I'm here with my colleagues Juan Chamali, Caleb Estelle, Yazabeth Guerrero Gomez, and Julia Zach, and we are doing a presentation on the analysis and redesign of a meat grinder. So a meat grinder is a machine that processes raw animal meat by breaking it down with the use of sharp blades and a hand crank. Some of the primary customers for meat grinders would include butchers and supermarket meat departments. They would primarily use meat grinders for breaking down raw meat and selling to consumers as packaged goods. Secondary customers would be restaurant chefs and at-home cooks who are making their own meals from scratch. Here's the CAD drawing for a meat grinder. The top part is the hopper, where the actual meat goes in. The middle part is the body, where the meat is grinded and ejected through the extruder. And the bottom part is the table mount, where the apparatus is mounted to a table. Here's the exploded view of our CAD drawing. This includes 11 unique parts, which we use for our analysis and redesign.
The FAST diagram illustrates how the primary function of the meat grinder is broken up into sub-functions which guide our design decisions. The main function of the meat grinder is to grind animal meat. We then ask the question, how will our grinder achieve this? This can be done by inputting, cutting, and extruding the meat. Some of these sub-functions are broken down further, which ensures that we explicitly state each terminal function. The four functions which are present in every FAST diagram are shown in red. In order to assure dependability, we must engineer the grinder to prevent injury by enclosing dangers and making it easy to control. The grinder is more convenient when the cleaning process is streamlined, and the product is enhanced when we include a way to control the granularity of the meat when it is extruded. The function component mapping matrix is a way for us to map each function from our FAST diagram to a component on the grinder. This ensures that each component is serving a purpose and that each function of the grinder can be fulfilled. One part to notice is the streamline cleaning function. Every component in the grinder must be engineered for ease of cleaning, since cleaning up raw meat is critical to food safety. Additionally, even a single hard-to-clean part can ruin the purpose of the grinder by harboring bacteria. From our analysis, we see that each part we have identified is serving a function and that every function is being covered by at least one component.
Two different assembly sequences were identified as feasible for this product. The major differences between the two sequences lie within the order of the subsystem's assembly. In sequence 1, after the barrel is assembled to the hopper, the shaft subsystem is assembled, followed by the cutter subsystem, then the crank subsystem, and finally the clamp subsystem. In sequence 2, after the barrel is assembled to the hopper, the clamp is then assembled, followed by the shaft subsystem, then the crank subsystem, and finally the cutter subsystem. When compared to one another, sequence 2 scored higher than sequence 1, with a score of 12 points compared to 10 points. Sequence 2 is identified to be easier to locate the parts, easier to fasten and join during assembly, and easier to test the subassemblies.